Hello friends, myself R.D. Mahajan presenting my video on curve tracing Cartesian type. First example, trace the curve y square into a plus x is equal to x square multiplied by 3a minus x with full justification. If we see the term here, we can express that equation for y in terms of x. That's why it is an explicit function Cartesian type. And to trace any explicit Cartesian equation or curve, we have to follow 5 points. The first one is symmetry. There are total 4 symmetries, out of which one exists here. For that we have to see the power of all terms of y. Here only one term of y and the power is even. And as all powers of y are even, curve is symmetrical about x-axis. Therefore justification is as all powers of y are even, therefore curve is symmetrical about x-axis. Means whatever the curve we have to draw, it must be symmetrical to x-axis. No any other symmetry exists here. Then the second point, origin and tangents at the origin. In this point, we have to discuss whether that curve passes through origin or not. By one simple way, put x and y as 0. If we put x and y 0, left hand side is 0. Right hand side also becomes 0. And as we get 0 is equal to 0, therefore curve passes through origin. Curve passes through origin, that is 0, 0. And as it passes through origin, we require to find the tangent at the origin. The procedure is find the lowest degree term of terms and then equate it to 0. If you see the lowest degree term on the left hand side, it is ay square. Degree of second term is 3. On right hand side, we have lowest degree term as 3a square. Combine and then equate it to 0. Therefore, minus 3ax square and equal to 0. It implies dividing by a throughout, we get y square is equal to 3 into x square. Taking square root on both sides, we get y is equal to plus minus root of 3 into x. Therefore, these are the two different tangents at that origin. And as we get two different tangents, therefore, that point is a node point. As we get two different tangents at the origin or at that point of intersection, that point is called as a node point. As the curve is symmetrical about x-axis, next point is we require to find point of intersection with x-axis, and the procedure is that put y is equal to 0. Therefore, if we put y equal to 0, left hand side is 0, right hand side is x square into 3a minus x. A product of two terms equals to 0. Equating each to 0, we get x is equal to 0, and second 3a minus x is equal to 0. From this we get x is equal to 3a, and therefore that points are x is 0 when y is 0. First point is origin 0, 0, and second one is x is 3a when y is 0. Therefore, we are getting two different points of intersection on x-axis or with x-axis. Then, whenever we have any other point of intersection other than origin, we require to shift the origin. And the purpose behind it that we require to find the tangent at that a new point of intersection. Then shifting of origin in the same third point, from suppose the original coordinates are xy, then from that way to shift it to 3a 0. The change in x coordinate is x plus 3a, and change in y coordinate is y plus 0, that is y. And as curve passes through this point, that point lies on that curve, and as it lies on the curve, it will satisfy that equation, and therefore we get a new equation as y square a plus x, x is x plus 3a is equal to x square x plus 3a whole square multiplied by 3a minus x, x is x plus 3a, and therefore we get y square multiplied by a plus 3a, we get 4a plus x as a term on the left hand side, and the term on the right hand side, if you expand it, it is x square plus 6ax and plus 9a square, that is multiplied by 3a get cancelled, we get minus x. And then from these two sides we have to find lowest degree term of terms. Here the degree is 2, degree 3, degree 2, and this one 3, degree 2 and degree 1. Therefore the lowest degree term is this last one, minus 9a square x equated to 0. It implies dividing by minus 9a square we get x equal to 0. X equal to 0 means y-axis as the tangent. At that point 3a 0. This is point number 3rd. Point number 4th, asymptote, which one type of line which becomes tangent to that curve at infinity. And if the curve is symmetrical to x-axis, we get asymptote parallel to y-axis. Therefore here we require to find asymptote parallel to y-axis as per the procedure or definition. And therefore to determine that asymptote parallel to y-axis, find the highest degree term in y. Here the highest degree term in y is y square into a plus x, only one term. Then its coefficient is a plus x. Equate that coefficient to 0. We get x is equal to minus a as asymptote. Therefore this line becomes the tangent to the curve at infinity. How to show, I will explain in that figure. Therefore here x is equal to minus a is the asymptote, and the region where the curve exists or where curve does not exist. And therefore as curve is symmetrical to x-axis, we have to solve the equation for y, and therefore solving this equation for y, we get y square is equal to x square 3a minus x and whole divided by a plus x. There are 3 terms containing x. Then we have to check for what values of x this term becomes negative, and therefore as the power is even, for any value of x it becomes positive. Then for this term, if x is greater than 3a, means suppose 4a, 3a minus 4a, we get that value as, we get y square as negative, and as y square is negative, y is root of that negative term, it becomes imaginary. Imaginary means curve does not exist for this region, x greater than 3a. Then we consider this one, second, a plus x. Using that we get, if x is less than minus a, any value which is less than minus a, minus 2a suppose, therefore a minus 2a we get minus, we get y square as negative, and therefore root of that negative, it is once again imaginary. Means curve does not exist. Means what is the region where curve exists? It is between the line x is equal to minus a to x is equal to 3a. Means whatever the curve we have to draw, it must be in between these two lines. And therefore, after discussing all these 5 points, we have to use these 5 points or convert these 5 points to a proper figure. Therefore, if the question is asked for 5 marks, for discussion we get 3 marks, and to draw that figure we get 2 marks. That is the scheme of marking always. Recurring xy coordinate system as it is a Cartesian type. First point, symmetry. Symmetry is about x-axis. Second, whether curve passes through origin. Yes, it passes through origin. Therefore, origin is one of the point. Then the tangents at the origin. We are getting tangents as y is equal to plus root 3x, root 3 into x, and minus root 3 into x. Therefore, I will show that two tangents. Two different tangents passing through origin. This is y equal to root 3 into x, and this one is y equal to minus root 3 into x. And as we are getting two different tangents, therefore that point at origin is called as node point. Two different tangents at the same point, then it is called as node point. Then the point of intersection. There are 2 points of intersection. One is origin and second one is 3a0. Therefore that 3a0 by some suitable distance, a, 2a, 3a. Suppose somewhere here approximately that point is 3a0. 3a0, the tangent is y-axis, a new y-axis. Therefore, I will show that y-axis. Therefore, this is the tangent at that point of intersection. And due to tangent, the shape of the curve, whatever we have to draw, it must be parabolic. Then and then only we get a single point of intersection. Then asymptote. Asymptote is here, x is equal to minus a. Therefore, this same distance. Therefore, this line x is equal to minus a as asymptote. Asymptote means this line become a tangent to the curve at infinity. How to show it, I will explain. Then the region where curve exists or where curve does not exist. This point is minus a, 0, and this point is 3a0. Region is in between minus a to 3a. We have to draw that curve between these two lines. Here, as this line is tangent, the shape of the curve, whatever we have to draw, it is slightly parabolic. A small parabolic part I will show. Then curve is passing through origin and this line is a tangent, means curve does not cross anywhere other than origin. Therefore, we have to join this origin to this, keeping that curve below that line. we get this part. Symmetrical part about x-axis, I will show that symmetrical part about x-axis. We get a loop. Then on this side, this line is the asymptote, means it is a tangent at infinity. And to make it tangent at infinity, a part of the curve we have to draw a parallel to that asymptote. A slightly parallel part I will show, and symmetrical on this side also. When we show like this, it means that that line becomes a tangent at infinity. That point is not possible for us to show in the figure. And then join this origin to this smoothly. It is not a linear curve, it is non-linear curve, and therefore we have to draw smoothly, we have to join it smoothly to this, and then have a symmetrical part about x-axis to this part. Therefore I will join this, and therefore whatever the figure I have drawn, it represents this equation y square into a plus x is equal to x square into 3a minus x. Important points I have shown in the figure. Symmetrical about x-axis, passing through origin, tangents at origin, these two are the tangents, and as we are getting two different tangents, that becomes a node point. Then point of intersection, one is origin and second one is 3a 0. By shifting of origin we get this line as a tangent. And as that line, this line is tangent, the shape of the curve is a parabolic. Why on this side? Because curve does not exist on that right hand side of that line. Then join this parabolic part to this origin by keeping in mind that this line is a tangent. Therefore it will touch only in the origin. Don't cross anywhere to that line. And then symmetrical portion about x-axis. Then next point is asymptote. This line x is equal to minus a is the asymptote. Therefore we make a parallel part to this line. Then join that parallel part smoothly to this origin. Means if you observe, the curve exists between these two lines only. X is equal to minus a to x is equal to 3a. Curve does not exist on this side and curve does not exist on this side. Means curve exists between these two lines only. This is the conversion of that discussion into proper figure. A size of figure must be a proper, that should not be too small or too big. And it is with all notation in that figure. If you complete like this, then you will get that 2 marks. In my next video, I will discuss one parametric curve tracing. One example of parametric curve tracing. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.